Topic 3 test review starting at number 1. Okay, the first 2 pages are testing what you know about transformations. Okay, you're not necessarily performing them, it's just testing what you know about them. Okay, so number 1, it says suppose, what does this mean? Oh, not that. What does that mean right there? Triangle, RST, that's our original, is translated. What does that mean? Moved, right? Slid. And then reflected, what does reflected mean? Flipped. To form our new image. Remember those prime symbols? That means our new image. Select all the statements that are true. Okay, what this wants you to understand is if I translate, reflect, I'm going to add rotate in there. Translate, reflect, rotate, what are those 3 things called?
Rigid motions.
Rigid motions, okay? If I am moving an object with one of those 3 rigid motions or multiple, is anything specifically happening to our image? No. Other than it's being moved. Okay? Everything about that image is going to stay the same. Capiche? Okay? So looking at this one, the length of our new RS, okay, this means line or segment. The length of RS is 4.3. Well, what's the original length? Is it 4.3? No. So can this be true? No. What does this little symbol mean? Congruent. Yep, this symbol right here means congruent. So this is asking if angle R is congruent to angle R prime. Is that going to be true? Yes. Okay, like I said, nothing happens to the angles. Angle R is going to be congruent to the new R. The measure of angle T prime is going to be 71. Is that going to be true? Yes. Why is that true? Because the original is 71. Good. ST is congruent to TS. True or false? It is true. Doesn't matter the order. No. ST is congruent to TS. TS is congruent to ST. Okay, does not matter the order on those. And then this last one, length of RT is greater than the new RT. True or false? What's wrong about that? It should stay the same, right? This should say equals instead of greater than. Okay? What? Number 2, I agree. Some of us, as myself, are visual learners. Okay? If you want to, on Thursday, you can grab graph paper. Okay? I'm going to show you a little trick. I'm going to draw a makeshift coordinate plane on this side. Okay? My point that they gave me is -2, 5. Do you agree that that is right here? In that vicinity. Okay? So -2, 5. It wants us to reflect across x equals 0. On the test, I called that the y-axis. And then y equals 0, which is your x-axis. Okay? So reflecting across the y-axis first. How far away are we from the y-axis? 2. So I need to go 2 on the other side. What's this coordinate right here? 2, 5. Yep. So I'm here right now at 2, 5. Second part was reflect over the x-axis. How far away are we from the x-axis? 5. So I need to go 5 on this side. What coordinate is that? 2, -5. So that's your answer. 2, -5. Okay. So if pictures help you, draw pictures. If you still want a piece of graph paper, please use graph paper if you need to. Okay. Number 3. Read the directions first. It says PQ is reflected across the line x equals -1. Select all that apply. So we need to perform the reflection. Okay, where's x equals -1? Right here, right? Is my line going to be up and down or side to side? Up and down, yep, because that's the only x value I want to touch. Okay, so that line is up and down. Now I want to reflect across that line. What happens to P? P stays in the same spot. How far away is Q? 3, so we need to go 3 on the other side. And then draw your picture. Once you have done the reflection, then you can answer the question. Okay, is PQ congruent to new PQ? Yes, remember with these rigid motions, everything is going to stay the same. Okay, Q prime or new Q is plotted at -4, 4. True or false? That is true. Q prime is plotted at -4, -4. True or false?
False.
False. Okay, next one. Q and Q prime are in the same quadrant. True or false? False. What does quadrant mean? The four corners, right? The boxes. 1, 2, 3, or 4. Okay, so D is false. P prime and P are in the same quadrant. True or false? True. So I would select A, B, and E. Number 4 looks very similar to the IXL I had you guys do over compositions. Okay, again, what does composition mean? What'd you say? Composition means more than 1. Okay? Biggest thing on this is what? No, you have to make sure you're going from the correct one. Which one's my starting image? The one on the right, and then this is the one I am ending at. Okay? I want to hear how you guys thought through this question. Instead of trying to figure it out on your own, okay, go through all of the options. Okay? Don't make your brain work harder than it has to. Okay? Process of elimination here. It doesn't matter what point I choose. No, you can just do one of them. Okay? I'm going to pick C. So if I'm following question A right now, or option A, it says we're translating 5 units left. Is that going to get me to my new value? No. So A is out. B says reflection across x equals 0, which is the y-axis. So how far away am I from the y-axis here? 2. So I need to go 2 over here. And then the second part says translation 5 units left. Is that going to get me to my new C? No. So option B is also out. Option C, reflection across y equals 0, which is the x-axis. Good. How far away are we? 1. So I need to go 1 on this side, and then it says 5 units to the left. Does that get us there? Yes. If you still weren't 100% sure in your answer, check the last one. Rotation 90 degrees about the origin. Let me ask you this. Do we even need to do that? Why not? Right, you can look. For 90-degree rotation, how many quadrants should it move? Only 1. How many does it move? 2. So that is also not an option. So C is the only one that worked. Okay, take that problem, process of elimination. Go through all the options. How you know which one the original is, it's the one without the little prime symbols. So all of these have the little tick marks here. So the ones without those tick marks is the original image. Number 5, here, again, if you're a visual person, there is graph paper available to you. I'm going to show you a little trick, okay? Here it gave you the original and the new. And what operation's happening? Not operation, transformation. Translation, right? So translation, that's the one where we see how much we're moving left or right or up and down. Okay, so from my original point here, I'm going to go from x to x, y to y. How did I get from 2 to 5? Plus 3, right? So I took my x plus 3. How did I get from 3 to negative 4? Y minus 7. Okay, so what I just made right there is the rule. Okay, now it wants to know the coordinates, the new coordinates for our original coordinate here is 6, negative 2. So the rule that I just made, we're going to apply it to our coordinate here. Okay, so 6 is x, negative 2 is y. So my new x, 6 plus 3 is 9. And then negative 2 minus 7, negative 9. So my answer is C. Okay, so you make your rule and then apply your rule to the coordinate that it gave you. And then we took 6 out. Question for you. Which transformation is not a rigid motion? Dilation. Good. Second page here. Number 7 through 10. Is it asking you to perform, let's say on number 7, is it asking you to do that whole composition to the whole image? No. What's it asking you to do? Just one coordinate, okay? So pay attention to the coordinate that it's asking you. This one wants us to do S prime. Again, that y equals 0, that is our x-axis. So how far away is S from the x-axis? 2, so I need to go 2 on this side. And then translation, 1 unit left, 2 units up. What's my new coordinate? Negative 1, 4. Okay, so I'm taking each transformation one step at a time. Okay, on number 8, it did not tell us specifically which direction, but I told you guys to do clockwise yesterday. I did specify on the test which one to do. Okay, so R prime, what are the coordinates to R? 3, negative 3. 90 degrees clockwise. If I look up there, our rule says turn it to y, negative x. So what is my new r going to be? What's my original y? Negative 3. What is my opposite x? Negative 3. Good. So from here, the rotation about the origin is here. So now I'm at negative 3, negative 3. The second part of that says reflect over the y-axis. Okay, so I'm at negative 3, negative 3. How far away am I from the y-axis? 3. So I need to go 3 this way. What's my new coordinate? 3, negative 3. Yep. Good. Similar for t. What is my old t? T coordinate? Negative 2, 1. I'm following that same rule from earlier. Y, negative x. What is my new t coordinate? My original y is 1. My opposite x is 2. So I'm at 1, 2. And then the second part of that is reflect over the y-axis. How far away am I? 1. So I need to go 1 on this side. What's this coordinate? Negative 1, 2. Last one here. Now we're focusing on q prime. Q prime here, we go 2 units to the right. 1, 2. And then reflection across the y-axis. How far away are we? 3. So I need to go 3 on this side. So what is that coordinate? Negative 3, 3. Okay, so make sure you're only doing the point that at once. You do not have to do the whole image. Okay. Number 11 is talking about the 3 symmetries. Okay. We're talking about a rectangle. So if I draw a rectangle here, what were the 3 symmetries? What was the first one? I heard someone say it. Reflectional. What does reflectional symmetry mean? I can split it in half, right? If I draw a line here, if it folds on top of each other, that has reflectional symmetry. Okay, I have another one here. So does a rectangle have reflectional symmetry?
Yes.
Yes. Okay, what was the next type of symmetry? Rotational. What is rotational symmetry? You can rotate it any amount of degrees as long as it's less than 360. Okay, so does a rectangle have rotational symmetry? Yes, because I can flip it upside down. What was the last type of symmetry? Point symmetry. What does point symmetry mean? 180 degree rotational. So does a rectangle have point symmetry? Yes. Okay, so by what we did on the side, we know a rectangle has all types of symmetry. Okay, so here it says what type of symmetry does a rectangle have? We picked the best one. Which one is it? C. Yep. Good. Number 12, it says if a figure is translated, remember translated just means moved left, right, up, and down, 3 units left and 3 units up, which translation moves the image back to the original position? How did you get A? Or why did you pick A? Think opposite, right? You're going backwards. Okay, so what's opposite of 3 units left? 3 units right. What's opposite of 3 units up? 3 units down. Yep, so you do get A. All right, number 13. I changed it on the test. We're going to take some notes so that you can be prepared. Okay, we're going to talk about a regular polygon. Okay? There's 3 things we know about a regular polygon. What are they? All sides are the same. I say all sides are equal. 2 more things we know. Specifically with symmetry.
It's going to have on the side that has that entire rotation or reflectional symmetry.
Yep. Number of sides equals the number of reflectional, I'm going to reword that, lines of reflection. There's one more thing about regular polygons, specifically with symmetry. What'd you say? I could add that to this one, and angles. Does a regular polygon have reflectional symmetry? Yes. Does it have rotational? Yes. Does it have point symmetry? Yes. So it has all symmetries. Okay, so ignore question 13. If I was talking about an octagon, okay, how many lines of reflection does an octagon have? 8. Where'd you get that from? The number of sides. Yep. Does an octagon have rotational symmetry?
Yes.
Does it have point symmetry?
Yes.
Yes. Does it have reflectional symmetry? Yes. That's what the problem's going to look like tomorrow. Okay? It's going to give you a shape. It's not going to be an octagon. It's going to give you a regular polygon. Okay? You use these 3 things that you know about those regular polygons to answer the question. Okay? All right. I took 14 off. I turned number 14 into 2 true and false questions. Okay? And then number 15. What do you notice about number 15? It's the same as the one on the front, right? Same as number 5. Okay? How did we go about solving this problem?
We just figured out how many moves.
Right, we got to figure out the rule and what happened, okay? How did I get from -2 to -6? X minus 4. How did I get from 3 to -4? Y minus 7. Yep. So then take the coordinate it gave you. What's 5 minus 4? 1. And then we have -1 minus 7. -8. So my answer? B. Good question. You can think of this as a number line. Okay? If I have -2 here, that's my starting point. And I have -6 here. That's my new point. How do I go from here to here? So I'm subtracting 4. Does that make sense? So if it helps, you can think of this as a number line. Okay? And you can do the same thing for the y's. How would I get from 3 to -4? And you're subtracting the distance. Yep, good question. On this page, how many transformations did we learn about in this chapter? 4. How many questions are there? 4. So you have 1 of each. Okay? On number 1, it says a reflection across x equals -1. So biggest thing, we need to draw this line of reflection. Okay? X equals -1 is here. Is my line up and down or side to side? Up and down. I'm going to ask you something real quick. What if I had y equals 2? 2's here. It would have to go side to side, right? Okay? Now reflecting, how do we perform reflections? Count the distance. Yep. What happens to R? R stays. How far away is T from the line of reflection? 4. So we need to go 4 on the opposite side. And then what about S? 4, 4. And then draw your picture. How can you check if you did them correctly? If you could flip it. Yep. Think flipping. And it should stay the same size and the same shape. Okay? Questions on reflections. Number 2 is dilations. How do we perform dilations? Right. You take each coordinate and you multiply it by the scale factor of whatever it gives you. Okay, so what is my coordinate for Q? 1, 3. What am I multiplying by? 1/2. When you're multiplying, remember, think you are distributing here. What's 1 times 1/2? 0.5. Yep, if you think decimals, that works too. What's 3 times 1/2? 1 and 1/2 or 3 over 2. When you graph these, do they have to be perfect points? No. Okay, so 1/2, 1.5 would put you here. Then you would do the same process for each coordinate that you have on there. How can you check your answers on dilations? Right. Seeing your scale factor. Right now, should this get bigger or get smaller? Smaller is reduction. Okay, so we should be smaller than our original. Okay? Number 3, rotation. Please, please, please do not panic when you see the word rotation. Why? So I feel like sometimes when we see the word rotation, we panic. What do we go to? The board, yes. I have the formulas up there for a reason. Use those. Do not panic, okay? So it says rotation of 180. I'm going to take the rule off the board. Okay, the rule tells us that our original coordinate, what's happening to it? Swapping signs, right? So let's just do coordinate S. What's my original coordinates for S?
-1, -2.
1, -2. Yep. Remember, these negatives in here in our formula, that means it's switching the original sign, going to its opposite. Okay, so what's the opposite of 1? -1. What's the opposite of -2? 2. So -1, 2 is here. How can you check if you did the rotations correctly? Specifically with 180 degrees, how many quadrants should it move? Should move 2. Okay, so if we're in this coordinate, quadrant, what quadrant should we end up in? Top left, right? Are we on the right track so far? Yes. Okay, use that to check. If you move 90 degrees, how many quadrants are you moving? 1, and then you just have to pay attention to the direction. Okay? Last one here on this page is translations. This one, it told you in words what's going on. Okay, I'm not going to guarantee you that it's going to be in words on Thursday. Okay, what's a different way you could see 2 units right?
X plus 2.
You could see this as x plus 2. What's a different way you can see 7 units up?
Y plus 7.
Y plus 7. Another way you could see it is in coordinate form. Okay, all 3 of those mean the same exact thing. Okay, with translations, what do we do to each coordinate?
You just move it from where it says.
Right, you listen to what it says. So if I'm moving G, I go 2 units right, 7 units up. And that's G. What do I do to all the other ones?
Same thing.
Same thing. Okay? Any questions on performing the transformations? All right, last page. On this back page, we are writing the rule. How many problems are there? 4. How many transformations are there? 4. So you're going to have 1 of each. Use that to help you. Okay? What transformation's happening on number 5? Dilation. Yep. How do I write the rule for dilations? Dilation of, what am I missing right now?
Enlargement reduction.
You can say enlargement reduction. What's happening?
It's getting bigger.
Getting bigger, so that's an enlargement. What am I missing? Scale factor, the number, right? How do I find the scale factor? What'd you say? Yep, so we're going to pick a point. Doesn't matter which point. No, I'm just going to pick W. What is my new W coordinate? 4, 0. What's old W? 2, 0. How do I figure out what the scale factor is? Divide. What does it have to be? Old divided by new divided by old. New divided by old. Okay, so we take 4 divided by 2, which is 2. So dilation of 2 or enlargement by 2. Either one of these, I don't care how you answer the question. Okay, I'll accept either one of those. I just need to know what transformation's happening and what the scale factor is. Okay? Number 6. What transformation's happening? Translation. Again, with the translation, I don't care how you write the rule. There's 3 options. I don't care which one you pick. Okay? What's happening in this translation?
It's moving to the left.
Left how many? Yep, so I could say left 4, or I can write x minus 4y, or I can write negative 4, 0. Either one of those 3, I do not care which one you choose. Okay? I do not care. Number 7. What transformation's happening? Rotation. What do we need specifically with rotation? Two things.
Your degrees and your direction.
Direction and degrees. Okay? How many quadrants am I moving? 1. So how many degrees is that? Yep. Rotation 90 degrees. Which one's my original image? The bottom one. So I'm going this direction, which is clockwise. Biggest thing when you're writing rules is making sure you're going from the original image. Okay, last one, number 8. What transformation's happening? Reflection, right? It's the only one we haven't used yet. Reflection. How do we figure out the rule for reflections? We need to find the line of reflection, right? Find an old and a new point. I'm just going to pick W. How far apart are W and W prime? They're 4 apart. Well, what's half of 4? 2. So we need to find the middle here. Is my line going to be up and down or side to side? Yep. You want to split them in half, find that midpoint. Yep. Is that all I need to do? No, what do I need to do? You need to tell me what the line is, right? What is that line called? Yes. Reflection across y equals -2. It's y equals -2 because that's the point that it's going through on the axis. Okay? Any other questions over any of the review?